Okay, so we're looking at double replacement or metathesis reactions with aqueous ammonia. Aqueous ammonia is a molecular compound, and metathesis deals with ions. But when we have a molecular compound that's a weak base, or a strong base, or whatever, it'll hydrolyze water, form some ions here. These ions can react. Ammonium is an acid, but hydroxide is a strong base, right? It's also a good precipitating agent. Ammonium is not a good precipitating agent, because ammonium and group 1 salts are all soluble. Hydroxides are all insoluble except for which ones?
Group 1.
Group 1 and ammonium and calcium, strontium, and barium. The soluble hydroxides are also known as strong bases. Insoluble hydroxides like magnesium hydroxide is not known as a strong base because it just doesn't produce much hydroxide in solution. Does that make sense?
Mm-hmm.
And so people, would you ever eat sodium hydroxide?
No.
No, because it would probably kill you. But have people eaten magnesium hydroxide? Yeah, people have eaten that for medical. Milk and magnesia is magnesium hydroxide, right?
Mm-hmm.
But it doesn't kill you. Why? Because it's not a strong base. A strong base are the soluble hydroxides, right? It is quite basic, though. You don't want to eat too much of it, otherwise it could kill you too. Anything can kill you, including water, right?
Wait, too much water can kill you?
Too much water can kill you, yeah.
Like over a gallon or what?
I don't know. I was listening to the radio and they had some kind of contest up north last year, a drinking water contest. Did you hear about that? The person who won unfortunately died. They didn't drown themselves. They had some kind of there's some kind of disease related to overhydration. I forgot what it was called.
I drink about 3 liters of water per day. Would I?
I don't think you'll die. I think you're okay. 3 liters. They say you should have a gallon of water a day. Is what I learned when I was in school. But anyway, so even though this is molecular, we have to deal with these ions. Now, the thing that a lot of instructors do is they have you write it out like this. So we write out magnesium nitrate. But a lot of instructors will have you write ammonium hydroxide like this because that's really what's reacting, right? But I'd rather not have you write ammonium hydroxide. The reason I'd rather have you not write ammonium hydroxide is because you don't go to the store to buy a bottle of ammonium hydroxide. You go to the store to buy a bottle of ammonia, aqueous ammonia. And in that it has, yeah. And so it's just like, it's like the previous reaction we did with potassium sulfide. You buy a bottle of potassium sulfide, you don't buy potassium hydroxide and potassium hydrogen sulfide, right? Although that's what forms when it comes in contact with water. This is what forms when ammonia comes in contact with water. And so it seems, there's debate, a lot of people say, well, we'll put ammonium hydroxide here. But the rule is we just do it based on the reagents we purchase.
What's the state of matter of the NH3 in your formula there?
The state of matter is aqueous. Okay, ammonia can hydrogen bond with water. Ammonia is very soluble with water. However, if you left the cap off a bottle of aqueous ammonia, it would go flat because it'll start evaporating off as a gas. I mean, you can smell it. And so you could write gas as well. But usually for gases, we write things that are insoluble in water, like CO2. CO2 is nonpolar, water is very polar, insoluble. And so the convention is to write it AQ. All right, even though we write ammonia and water, we think of it as ammonium hydroxide, so we just form magnesium hydroxide, solid, and ammonium nitrate. And then we need to balance this. For every ammonia and water, we get 1 ammonium hydroxide, so we'll need 2 ammonias and 2 waters to get 2 ammonium hydroxides. So we need 2 hydroxides here. That'll give us 2 ammonium nitrates there. Now, I'm leaving off the aqueous here, which is perfectly fine. But don't put some on there and some blank, otherwise I'll think you don't know what that is. So I'm just going to leave this off. So this would be the complete equation. In the complete equation, I want you to show me the driving force. What would the driving force for this be? Yeah, the precipitate here. Magnesium hydroxide precipitate. All right, why don't you write the ionic equation and the net ionic equation for this? We'll be right back.